Oh yeah. Oh yeah. Summer is here. All right. I'm going to get started just because, like I said, I'm going to post this on my YouTube channel. So if you can't check this out live, which I totally understand, you'll have the ability to watch it later. We're going to be doing the multiple choice out of the June 2018 Regents, which is the last one in your review book. And if you have any questions, hit me up on Remind. All right, question one. Generally speaking, the first five-ish questions are going to be on atomic structure. So protons, neutrons, and electrons. Stuff about the atom. Which statement describes the charge and location of an electron in an atom? First thing we want to know is that an electron is negatively charged. Nope. Nope. Second thing we want to know is that electron is on the outside of the nucleus. So if you think of that Bohr model, the electrons are like the planets orbiting the sun. So, not in the nucleus. In the nucleus are protons and neutrons. Outside the nucleus are those negatively charged electrons. They also like to ask the vocabulary word associated with this, and we call that an orbital. 2. Why is a xenon atom electrically neutral? So when you see the word atom, you think its charge is 0. So having a charge of 0 must mean that the amounts of positives and negatives are the same. And from here, we have to remember that protons are positive and electrons are negative, just like in the question before it. If they're equal to each other, then you'll have a charge of 0. Neutrons are neutral, so anything involving charge, you can ignore neutrons. Isotopes means same element, which means the protons are the same. Because in order to be the same element, you must have the same atomic number. If you have the same atomic number, you have the same amount of protons. So, protons are the same. What's different in the isotopes is the mass. And since the mass is the protons plus the neutrons, and we already said the protons are staying the same, what must be changing are the neutrons, which was answer choice 2. Hold on, we're getting a few texts on Remind. Let me just see. All right, moving forward. Question 4. Which electrons in a calcium atom in the ground state have the greatest effect on the chemical properties of calcium? So chemical properties of any element, doesn't matter the fact that it's calcium, for any element is all about the valence electrons. And the valence electrons are the electrons in the last shell of any atom. So if we check the periodic table and go find calcium, its atomic number is 20. We got to look at the electron configuration. And when we look at the electron configuration, we notice that there are 2 electrons in the 4th shell, because we went 1, 2, 3, 4. So, if we go back to the question, we want to talk about the valence electrons, which in calcium there were 2 of them, and they were in the 4th shell. 5. The weighted average of the atomic masses of the naturally occurring isotopes of an element is the... So, we're talking about masses and we're averaging them, so we probably want to pick an answer choice that deals with mass. Mass number is simply the protons plus the neutrons, so it's not that. Formula mass is the mass of the individual atoms in a compound. So for example, you would say the formula mass of H2O is 2 times 1 plus 16. The 2 means the 2 hydrogens. The 1 means the hydrogen weigh about 1 each. And then that 1 oxygen is 16 atomic mass units, or 16 grams, however you want to think about it. and that is the formula mass, which are not isotopes. Isotopes, as we saw in the previous question, are same element, different mass. Therefore, this is the atomic mass of the element, which is what you see on the reference table. This is why their masses are all decimals. It's because they are the weighted averages of all the naturally occurring isotopes for that element. 6. Which element is classified as a metalloid? If we go to the periodic table, the metalloids are the ones on that staircase. Ignore aluminum. And we got boron, silicon, germanium, arsenic, antimony, tellurium, polonium. I don't know if PO is actually polonium. It probably is. Anyway, luckily for us in the question, they all give us their abbreviations, so we don't have to worry about going to table S and looking up what they are. We got chromium is a metal, cesium is a metal, scandium is a metal. There's our metalloid, silicon. Quick review. All of the metals are to the left. So as you go this way, we have our metals. And as you go this way, we have our nonmetals. That's important to keep straight. Comes up every year. 7. Which statement describes a chemical property of iron? So we want to pick something where iron is changing chemically. Something that makes the properties of iron different. Something that is hard or not possible to reverse. Melting's reversible. You freeze it, you melt it. The fact that it's a solid at STP, solid is a physical property because you can change that solid into a liquid and you can change the liquid back into a solid. Iron is attracted to a magnet is a physical property of iron. Some things are magnetic, some things are not. But when iron oxidizes, it rusts. That is hard or impossible to reverse, therefore is a chemical property. Graphite and diamond are two forms of the same element, but they're different things, so they have different properties. But the fact that they're the same element, in this case carbon, they're going to have the same atomic numbers because they're both made of carbon. They're going to have the same electronegativities because they're both made of carbon. And they're going to end up having the same empirical formulas because, again, they're just the same substance. They just have different structures, which means they look different. So crystal structure of diamond is a bit different than the crystal structure of graphite. Which ion has the largest radius? So the fact that it's an ion here isn't going to end up making a difference because since they're all negatively charged ions, they're all going to get bigger compared to their atoms. So if the question had you comparing atoms and ions, let's say F versus F minus, then F minus would end up being bigger than F because negatively charged ions gain electrons and they wind up getting bigger. Since these are all negatively charged ions, we can actually just look up their atomic radii on table S. I know that's confusing. Table S has atomic radius, not ionic radius, and the question's about ions. But again, since they're all in the same group, F, Cl, Br, and I are all in group 17, and since they're all negatively charged ions, means they're going to get bigger proportionally to how big they were to begin with. F minus isn't going to be drastically bigger than chlorine. It just can't, because chlorine naturally is bigger than F. The fact that it becomes negatively charged doesn't make it a million times bigger all of a sudden. So if we look up their atomic radii, fluorine right here, probably should use a highlighter, has an atomic radii of 60. Chlorine right here has an atomic radii of 100. You can probably see the trend, but don't make any assumptions. We're in no rush. Bromine has an atomic radii of 117. And then finally, iodine has an atomic radii of 136. So, who was the biggest? Iodine. Who's still going to be the biggest even though they're negatively charged, because that will make a difference in this case? Also, iodine. Carbon monoxide and carbon dioxide, they're not the same thing. They're two different compounds. And two different compounds will always have different properties from each other. Even though they both have carbon in it, they're going to behave differently. Carbon dioxide, produced by plants. Technically plants also produce it, but it's produced by many living things during respiration. Plants use it for photosynthesis. Carbon monoxide, poisonous. Different things are different. Based on Table S, which group on the periodic table has the element with the highest electronegativity? So, I think the easiest way to do this was to go to Table S and find the element with the highest electronegativity, and then go back to the periodic table and figure out what group it's in. So, Table S, I'm looking at this electronegativity column right here. I'm going to look down. So far, the biggest number I see is 4. Anything bigger than 4? Anything bigger than 4? Nope. 4 is the highest one. 4 is fluorine. Sorry, I didn't mean to back out of there. Let's scroll up to the periodic table. What group is fluorine in? Fluorine is in group 17. So, the groups are the ones that go up and down. The periods are the ones that go left and right. Periods. They're also labeled on there for you. Here's group. Here's period. So you'll notice, obviously, they're going to put group 2 as an option because fluorine is in period 2, and there's always going to be an answer. They're not trying to trick you. They're just trying to see that you know the difference between a group and a period. Fluorine was in group 17. Number 12. This was one of the highest missed questions on the Regents last year that I think is easiest to tackle as a process of elimination. Heterogeneous mixture means that this thing needs to have been mixed with something and be insoluble. We have no context that PbCl2 was mixed with anything. It's just a compound existing in a solid state. So it can't be a heterogeneous mixture because the problem didn't indicate that we were mixing it. A homogeneous mixture will have the symbol AQ next to it because homogeneous mixtures means that it mixes perfectly. The particles distribute uniformly throughout. As far as you can tell by looking at it, it's not a mixture because those particles have completely dissolved. All solutions are homogeneous mixtures, therefore it's not a solution. A substance, how do we define that? It's either an element or a compound. Since in number 12 we were dealing with a compound, means that it is a substance. What is the vapor pressure of propanone at 50 degrees Celsius? I would say this is a type of question where if you don't know where to go right away, try to see if you can just flip through the reference table and find something about propanone and or vapor pressure, and it might be able to help you. Don't go to Table S for questions like this. Table S just deals with elements. And I know no chemistry teacher has asked you to memorize all the elements, but propanone probably does not ring a bell. And it shouldn't because it's not an element. So we need to find a reference table that deals with vapor pressure. Luckily for us, Table H deals with vapor pressure. In fact, the title of it is Vapor Pressure for Liquids. So, first thing we need to do is identify propanone's line. Second thing we need to do is find the temperature in question. And the last thing we need to do is just see what the pressure is, which is the y-axis, at that temperature. Third thing we need to do is double check that we know the y-axis and how much each of those are jumping by. So what's the scale of our y-axis? Since it's 50 here and 100 there, it looks to me that it's jumping up by tens. So right here, we got 60, 70, 80. Should be somewhere in the 80s. Hey, that's an answer choice. 83. 14. Which statement describes the charge distribution and the polarity of a methane molecule? So, when you see the word molecule, you should think to yourself, snap. Symmetry, nonpolar. Asymmetry, polar. Now, since the question didn't tell you if CH4 was polar or nonpolar, and is relying on you to figure that out, the only way you should be able to do it is to draw it out. So, carbon has 4 valence electrons, which means it can have up to 4 bonds. There's 4 H's around it. So, those are our 4 bonds. Is this molecule symmetrical? I would say yes, because there are no lone pairs on the central atom. So that means carbon is just surrounded by bonds, no dots. And because they are all the same element around carbon. So if one of those was a fluorine and the other 3 were a hydrogen, I would say this is not symmetrical. But since there aren't any lone pairs and all of the bonds are the same type of bond, meaning all carbon-hydrogen bonds, I would say this is symmetrical. Then when I snap it, that means it is not polar. And I'm going to pick the answer choice that says both of those things, which is the first one. In a laboratory investigation, a student separates color compounds obtained from a mixture of crushed spinach leaves and water by using paper chromatography. The colored compounds separate because of the differences in chromatography. This is kind of a word association. When you see chromatography, you should say to yourself, polarity. Boiling point is distillation. That's the other common one they like to ask about. So, if you need to separate 2 liquids, you would use distillation because it will separate them based on their different boiling points. Malleability is a property of metals. That just means that you can hammer it into shapes. Electrical conductivity is exactly what it sounds like. Does it conduct electricity? 16. Ideal gas particles. So by now, you probably have in your head that ideal gases are most likely to behave ideally at high temperatures and low pressures. This is the kinetic molecular theory going way back into not even second quarter, way back to first quarter, maybe even as far back as September, where we learned all those rules about gas molecules. Do they attract each other? What's their motion? Do they transfer energy when they collide to things? So, this question only gives us answers about the attractiveness of their forces and their motion. So, gas particles move in random straight line motions and do not attract each other. And that's ideal gas. So, random straight line motions, no attractive forces. 17. This was a big missed question last year as well, one of the biggest ones in the state. At which temperature will Hg liquid and Hg solid reach equilibrium in a closed system at 1 atmosphere? It presents itself as an impossible question. How are you supposed to know when it will reach equilibrium? But notice that it is a phase change equilibrium. And you know what we have at our disposal that allows us to look up phase changes of elements is table S. This was a very hidden, very sneaky what is the melting point of mercury question, and it was hidden in an equilibrium problem, making it seem very difficult. A lot of students put 273 Kelvin, and you know why? Because they gave you 1 atmosphere, and 273 Kelvin is the temperature of STP. 1 atmosphere and 273 Kelvin is STP. It just doesn't answer the question. We need to look up what the melting point of mercury is. So just to show you what I was talking about, there's STP right there. You see 1 atmosphere, you played the association game. I remember seeing this before. 1 atmosphere is 273 Kelvin. That's STP. Unfortunately, we just needed to look up the melting point of mercury, which is atomic number, it's a big one, 80, yep. And its melting point is 234 Kelvin. Again, you can imagine how many students put 273. A lot. You would probably be in good company if you did this on your own and thought it was 273. I would totally get it. It's a hard question. A molecule of any organic compound has at least 1 carbon atom. Period. Another word association question. Organic compounds contain carbon. Can they contain oxygen? Yes. Do all of them? No. A chemical reaction occurs when they collide with proper energy and orientation. Think of you trying to, I always gave the analogy of putting your keys in the car to start it. If you put them in backwards, aka orientation, they're not going to get into the car to start it. You can't put the keys in the wrong way. Similarly, if you're very lazy about it and you try to slowly push the keys into the ignition, it's not going to start. You're not even going to get the keys in. If you try to turn it really weakly, it's not going to start the car. So that's what we mean by proper energy. The molecules can collide with the right orientation, but if they're moving too slow, they'll just bounce off each other and do nothing. Converting chemical energy into nuclear energy is just not really a thing we talk about too much. Have no attractive forces, that's an ideal gas. Are separated by great distances, that's also talking about an ideal gas. Systems in nature tend to undergo changes toward, this is lazy and crazy. Another acronym / mnemonic device / phrase that you've heard throughout the year. Lazy means low energy. Crazy means high entropy. Lazy and crazy. 21. Which formula represents or can represent an alkyne? So, this is another thing where we have to say to ourselves, what's an alkyne? And if it doesn't jump out at me, maybe the reference table can help. It can. So, alkenes, alkanes, and alkynes are all on table Q. It said alkyne and gave you a formula, so we have to check which one of the formulas given satisfy this formula of CnH2n minus 2. Go back to the question. We're trying to pick one where the hydrogens equal the carbon times 2 minus 2. Because the formula looked like this. All right. Number 1, 2 times 2 is 4. 4 minus 2 is 2. No. Number 2, 2 times 2 is 4. 2 minus 2 is 2. Sorry, 4 minus 2 is 2. No. Number 3, 3 times 2 is 6. 6 minus 2 is 4. Yep. 22. Which formula represents an isomer of this compound? So isomer means same molecular formula. So we're looking for one that has 1, 2, 3, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. But a different structure. Totally different structure. Don't just make it look kind of different. We're talking breaking a bond and moving that carbon somewhere else. Answer choice 1 has a double bond in it. The original formula did not. Nope. Answer choice 3 has a triple bond in it. The original formula did not. No. Answer choice 4 is the same as answer choice 1. They just took the carbon from up here and put it down there. But it's still attached to carbon number 2. It's still attached to the middle, therefore it is the same structure. Answer choice 2, that's a different structure, and it's still C4H10, therefore it's an isomer. Which energy conversion occurs in operating in a voltaic cell? So, voltaic and electrolytic cells was during the redox unit, which is electrochemistry. So it's all about electricity. So anything with nuclear in it, you can just cross out. You get it down to the 2 clear choices that could go either way. Answer choice 1 is voltaic. Answer choice 3 is electrolytic. Voltaic cells are like batteries. They produce the electricity. Electrolytic cells are the opposite. They need a battery to operate. Which process requires energy to decompose a substance? So, key idea here was energy and decomposition. Synthesis is bringing 2 atoms or 2 compounds together to form one compound. That's the opposite of decomposing. Sublimation is when you go from a solid directly into the gas phase. You need energy for that, but it's not decomposing the substance. The substance stays the same, it just changes phase. Neutralization is an acid-base reaction that, when they neutralize each other, form water and salt. So that's not it. Boom, electrolysis. Electricity. We need energy for here. Lysis, breaks apart, decompose. The concentration of which ion is increased when LiOH is dissolved in water? So, LiOH is a base. We know it's a base because it has hydroxide ions. So when you put LiOH in water, it's going to dissolve into lithiums and hydroxides. Now, look at your answers. We need to at least go through some process of elimination here to try to determine what the right answer could be. Halides are group 17. There's nothing from group 17 in this question. It gets a little difficult, and part of this is going to be a bit of memorization, but how would you know it's 1 and not 2? How do you know it doesn't form hydrogen ions? If it did form hydrogen ions, that would mean it's an acid. And these 2 answers, 2 and 3, are interchangeable for acids. They're both acceptable answers, which means you can't just have one without the other. So you can cross that out. In addition to this, you could look at that formula and say something from there has got to be on table E. And hydroxide is on table E right there. Mr. G, how do you know something was on table E? How can you tell by just looking at a formula that something's from table E? If a formula has 3 or more different types of elements, something most likely came from table E. So, for example, we were talking about PbCl2 before. PbCl2 is just 2 types of elements, Pb and Cl. I know that there's 3 total elements, but there's only 2 different types of elements, lead and chlorine. LiOH has 3 different types of elements. There's Li, there's O, and there's H. 3 different ones. Something is bound to have come from table E when you have 3 different elements in your compound's formula. So go check table E. Which equation represents neutralization? Well, we just went over that. It's an acid plus a base makes salt and water. We get a little lucky here. There's only one answer choice that even makes salt and water. Sorry, I should say. There's only one answer choice that even makes water. Answer choice 3. None of the other ones do. If you don't remember the products of neutralization, but you remember that it involves an acid and a base, you can always go to table K and L and see if any of the formulas in the question are on tables K and L. Because if you know what's the reaction between an acid and a base, yeah, you might not remember the products, but you can look up the reactants. In this case, I believe it was H2SO4 and KOH in your problem, which is an acid and a base. The stability of an isotope is related to its ratio of... We've already talked about isotopes in like 2 previous questions. It's about protons and neutrons. Isotopes mean same protons, different neutrons. So, we probably want to pick the answer choice that involves protons and neutrons. Which particle has the least mass? You read all these, you can say to yourself, I can look this up on table O. Go to table O. On table O, we have alpha particles, beta particles, protons, and neutrons, which were all the stuff that was involved in that question. The mass is the number in the top left. I keep covering it up. The mass is the number in the top left. The bottom left number is the charge. We want to pick one where the answer choice has the least mass. Alphas is 4, betas is 0, proton and neutrons are 1. Correct answer, beta. The energy released during a nuclear reaction. Aha! Nuclear. So, this one's going to get tricky. You initially want to barf it. Barf means breaking bonds absorbs energy, and releasing energy forms a bond. The issue is that's only true for chemical reactions, not nuclear ones. Nuclear, thank you,
You're welcome.
is all about
Do you want
producing... No, I actually kind of like it with the natural light because it doesn't blind me.
Wow, fancy.
Yeah, I'm a fancy guy.
You are.
Nuclear reactions is all about taking small amounts of matter and converting it into large amounts of energy. Think about fission and fusion. I'm sure your teachers talked about the atomic bombs. They were just using that small amount of matter and creating a whole lot of energy from it. Nuclear power plants do the same thing. All right, 30. Uranium-238 is used to determine the age of a geological formation is a beneficial use of... This one kind of seems a little tricky at first. Might seem hard to get the right answer from process of elimination. But since it's a nuclear question, let's just see if it's on table N. And it is. It is on table N. And what that means is that it's a natural process. There is no other required reactant for this to occur but uranium-238. And table N is called selected radioisotopes. So, since it's a natural reaction, it is not fission or fusion. Fission and fusion might occur naturally, but they're considered artificial nuclear reactions because there are 2 reactants. That table was called radioisotopes, not radioisomers, so be careful. That's it for the first 30. Shoot me a quick text, the 3 of you that are here watching, if you have any. If not, I'm going to keep going because I'm going to put this up on my YouTube channel. And the shorter, and I don't want to get through this fast, but the shorter the video, the easier it is to upload to YouTube, and the more likely students will watch it. So, moving forward, which elements are present in this mixture? So, This is all about just matching the elements' lines to the lines that are in the mixture. So, let's start with A. Yep. 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 Great. Let's go to D. Oop, sorry. D is over here. Up. D's not in the mixture. Can't be D. Let's cross those out. See ya. Now, since we already identified that all of A's lines are in the mixture, answer choice 4 doesn't even have A as an option, so the right answer must be 3. We can confirm it by checking X. Yep. 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 Okay. Cool. Each line in the spectra represents the energy, blah, 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 blah. They ask this question every single year. Might be short answer, might be multiple choice. In my experience, it favors the short answer. It's all about electrons moving from excited to ground state. That is when you see the spectral lines. When an electron moves from an excited to a ground state. There's only one answer choice that says that, and that's answer choice 4. If there are multiple answers that said that, you want to pick the one where the energy is released. So what's happening is, when you excite these atoms, you're putting energy into the atom. And the electrons are going to get excited and jump up in energy level with all that absorbed energy from, let's say, fire. When the electrons jump down to the ground state, they release that energy that they absorbed in the form of light. So, keyword is, it's going to release the energy as the electrons move from excited to ground state. They also might say the word emit instead of release. Which ion has a charge of -2? So, when I see a negative charge, we're going to have more electrons than protons. Neutrons are neutral. Neutrons have no charge. So, anything about neutrons we're going to ignore. So, who cares about you? Since the charge is 2 negative, that must mean we have 2 more electrons than we do protons. Luckily for us, the first one right here has 2 more electrons than protons, therefore is -2 charged. What is the mass of an atom that contains 26 protons, 26 electrons, and 19 neutrons? Electrons don't matter for the mass, so we're going to ignore it. Mass is protons plus neutrons. So here we're going to do 26 plus 19 and get 45. Which electron configuration represents a potassium atom in the excited state? First, let's get potassium in the ground state. Potassium in the ground state is 2881. 2881. Excited means the total amount of electrons stays the same. In this case, 19 electrons. You just take one from a lower level and move it up to a higher level. Keep the amount the same. So, for example, let's go through the answer choices and try to spot any that contain a different amount of electrons. 2 plus 7 plus 6, that's 9 plus 6, that's 15. 2 plus 8 plus 5, that's 10 plus 5, that's also 15. 2881 was the ground state that we just wrote down. Therefore, 4 is the right answer. What happened in 4? An electron moved from energy level 3 up to energy level 4. The total on both sides is 19 electrons, but on the right side, we would say this is excited because an electron moved up to a higher energy level. What is the total number of neutrons in an atom of K42? 42 in that notation means the mass. We just did a problem involving mass. Mass equals protons plus neutrons. Mass equals protons plus neutrons. Well, we can look up how many protons potassium has on the periodic table. 19. So, if this is 19, how many neutrons does it have? Do 42 minus 19 and you'd get 23. What is the number of moles of carbon that must completely react to produce 2 moles of ethane? So, anytime you have a mole problem involving more than one substance, do not use the mole equation on your reference table. I repeat, do not use the mole equation on your reference table. If you see 2 different atoms and a problem involving moles, you are going to use the balanced equation provided to you. Normally, from the balanced equation, 2 carbons make 1 ethane. However, the problem says, how is it going to be different if you have 2 moles of ethane? Cross multiply and divide, and you'll get 4, because 2 times 2 is 4. So again, when you have a problem involving moles and involving 2 different substances, meaning the problem did not ask how many moles are in 10 grams of carbon, the problem asked how many moles of carbon are going to react if you have 2 moles of ethane. 2 different substances means set up a proportion. Do not use the mole equation from the reference table. When you go to the balanced equation, normally 2 carbons make 1 ethane. So they're in a 2-to-1 ratio. So if I double my ethane to 2, how will that change my carbons? Cross multiply and you get 4. Which type of chemical reaction is represented by the equation? Well, from what I can see, we have an Mg coming in and an H going away. Look at that. Mg is now with Cl. H, bye. That means it's single replacement. One atom replaced another. Synthesis is 2 things become 1. Decomposition is 1 things break up into at least 2 or more things. Double replacement is a double switch. So that would be like 2 compounds reacting and A and C switch with each other. Double switch, double replacement. It's like do-si-do. Based on this table, which statement describes how 2 of these elements can be differentiated from each other? Be careful. You just need to read the table correctly. 1. Gold can be differentiated from tungsten based on density. Gold, tungsten, no. Gold can be differentiated from sodium based on malleability. Gold, sodium, no. Sodium can be differentiated from tungsten based on its conductivity. Sodium, tungsten, no. And last one is the answer. Which particle diagram represents a mixture? So, we need a particle diagram that's composed of 2 or more different substances. Those 2 are the same. Nope. Those 2 are the same. Nope. Those are all the same. Nope. 3. This is a compound, this is a compound, and these are elements. An atom of which element reacts with an atom of hydrogen to form a bond with the greatest degree in polarity? The greatest degree in a polarity of a bond is all about electronegativity. You want to pick the answer where the atom has an electronegativity that is the furthest away from hydrogen when compared to all the other atoms. Meaning, you want to pick the answer choice of the atom that has the highest electronegativity compared to hydrogen if they're all bigger than hydrogen's electronegativity, or if they were all smaller than hydrogen's electronegativity, you want to pick the one with the smallest electronegativity. And you know where we go for that? Table S. So, carbon, 2.6. Nitrogen, 3.0. Oxygen, 3.4. Fluorine, 4.0. Hydrogen was at 2.2. Since they are all higher than hydrogen's electronegativity, we want to pick the answer choice that is the highest electronegativity. Fluorine. What is the concentration of an aqueous solution that contains 1.5 moles of NaCl in 500 milliliters of this solution? So, big M, when you see that, that means molarity. If you have a unit that you do not understand the meaning of, you can go to table D. Big M means molarity. There's a formula for that on the reference table. Whoops. So go all the way to the last page now, and you can get the formula for molarity. Molarity is moles per liter. Uh-oh, we gotta be careful. Moles per liter. My moles is 1.5. My liters is not 500. Luckily for us, none of the answer choices are 1.5 divided by 500. So you would say, okay, I did something wrong. To convert milliliters to liters, simply divide it by 1,000. Or move the decimal to the left 3 times. So this is 1.5 divided by 0.5, which is 3. Which two gas samples contain the same number of molecules? Usually they ask this in terms of volume. Equal volumes mean equal number of molecules, but they kind of tricked you a little bit because they gave you the other conditions. But approach it the same way. Equal temperature, volume, and pressure conditions will mean equal number of molecules. There were only 2 that have the same exact conditions, and that's 2 and 4. Based on table I, the worst reference table, what is the delta H value for the production of 1 mole of NO2 gas? Something tells me that's going to be important. From its elements at 101.3 kPa and 298 Kelvin. So, we got to go to table I. We got to find NO2 gas. NO2 gas. Do you see why I hate table I? Because right above NO2 gas is 2NO gas. Why do they do that? I don't know. This reference table is the worst. So, there's NO2 gas, and that's 2 moles of NO2 gas. And 2 moles of NO2 gas has a value of 66.4 kilojoules. Kilojoules? Yes, kilojoules. So normally, 2 moles of NO2 gas gives you a positive 66.4. Let's get rid of these negatives before we make a silly mistake. What happens if you have 1 mole of NO2 gas? So, if 2 normally makes 66.4, 1 will make how many? Well, when you cross multiply and divide, you will just end up dividing both sides by 2, which means the right answer is 33. Which equation represents an addition reaction? An addition reaction is really simple. It's exactly like synthesis, except it involves organic compounds. You're going to take 2 things, and you're going to smush them together. Boop, that one. Answer choice 1 is substitution. If you look carefully, 1 Cl comes in, and an H pops off. Answer choice 3 is double replacement. The calcium and the sodium switch places with each other. Now the calcium's with carbonate and the sodium's with chlorine. Answer choice 4 is decomposition. One thing broke apart into 2. 46. Given the balanced equation representing a reaction, in this reaction, each nickel atom blanks. All right, we're dealing with electrons here. The fact that we're all electrons means this is a redox reaction. We need to figure out the oxidation state of nickel on both sides. So, nickel on the left side, no friend, no charge. If anything is bonded to, let me reword that. If you have any element bonded to only itself or bonded to no one, it does not have a charge. Its charge is 0. No friend, no charge. Nickel on the right side is bonded to chlorine. So, let's get the oxidation state of nickel from the periodic table. Oh no, nickel has two choices for a charge. It can be +2 or +3. How do I know which one to pick? Well, if you know nickel is only possible oxidation states are positive, that means chlorine's oxidation state must be negative. And chlorine only has one possible negative charge, -1. So, I know chlorine has to be negatively charged. Since chlorine is -1 and there's 2 of them, that means the 2 chlorines have a total of -2, which means the nickel must have a charge of +2 so that those cancel each other out and we get a total charge of 0. So, nickel went from 0 to +2. If the charge gets bigger, it's getting oxidized. If the charge gets smaller, it's getting reduced. I like to approach it from the side of reduction because I know that when something gets reduced, it gets smaller. And if the charge gets smaller, it must get reduced. The charge is getting bigger here, so it's not getting reduced. Then apply the acronym LEO says GER. Lose electrons oxidation, gain electrons reduction. Well, we just said we were getting oxidized, so we must be losing electrons. Since it went from 0 to +2, it must have lost 2. Which equation represents a reduction half reaction? So, let's apply what I just talked about. Reduction. We need to pick an answer choice where the charge is getting smaller, because getting smaller means the same thing as reduced. 0 to +3 is getting bigger. 0 to +3 is getting bigger. Now, 3 and 4 show the same thing. A charge is getting smaller. What's the right answer? Now apply the acronym gain electrons reduction. We need to pick the answer choice that not only shows the charge getting smaller, but also shows the electrons being gained. Gained electrons will always be shown on the left-hand side of the reaction. They will be a reactant. Losing electrons will always be shown on the right-hand side of the reaction. They are a product. 3 more. Let's go! 48. During this reaction, electrons are transferred from, give yourself a 50% chance. This is not reversible, which means the electrons are being transferred somewhere between your reactants. Your products are set in stone. We're not reversing this. Any answer choice you see Cu +2 in, you can go ahead and cross out. It's just impossible. So, transferred from who to who? You could go to table J and look who's the anode and who's the cathode. So on table J, whoever is higher gets oxidized and whoever is lower gets reduced. So if we're comparing Cu and not Au, Cu and silver, you would say Cu is getting oxidized and silver is getting reduced. Then you say to yourself, red cat, reduction is cathode, and ox, anode is oxidation, copper must be my anode, silver must be my cathode, and electrons always flow from the anode to the cathode. So we want to pick an answer choice that shows them flowing from the anode of copper to the cathode of silver. But what if you didn't know that? What if you didn't know to check table J? We can see in the reaction that silver is getting reduced because it goes from a positive charge to a charge of 0, meaning its charge is getting smaller. Reduction means you're gaining electrons. So if silver plus is the one gaining electrons, you must show the answer that is gaining electrons. You don't want to say answer choice 4 because 4 says the electrons of silver are being lost and given to copper, which is just not happening. Which metal spontaneously reacts with Cr2 plus ions? This is a table J question. What confuses my students on a question like this is how do I know if I'm looking for an atom that's above strontium or below strontium? There's two ways to figure it out. First, if the question is giving you an ion, you're looking for something that's higher on table J because you want something that's going to be acting as the anode, not the cathode, much like the previous two questions. If you couldn't remember that, play the game one of these things is not like the other. 3 of those answer choices will be below strontium. We don't want to pick any of those 3 because how could you know which one is the right answer? They're all below strontium. We want to pick the answer choice that's higher than strontium on table J, which if my memory serves me right, is CS. And it is. CS is higher than strontium, which means the correct answer is CS. 50. The water molecules act as a base because, well, there's water, there's H3O, so water gained an H to become H3O. Accepts an H. Bases accept H plus or protons, and acids donate H plus. You might not even have to have looked at the reaction because as soon as you see base, you would go accepts an H. All right, that's it for tonight. I'm going to post this on my YouTube channel later once it's done doing its magic. Other than that, thank you for tuning in. We're going to do the short answer questions tomorrow. Have a good night, everybody.